The universe is shaped by forces we cannot see. Gravity, dark matter, black holes, the birth of stars, and the explosions that create entire worlds. These forces built galaxies, created planets, and made life itself possible. This is the story of the forces that shape the universe. Why are you stuck to Earth? Right now? Seriously? Why don't you suddenly float into space? Why does every object you drop fall down? The answer is something completely invisible. Gravity. A force so powerful that it shapes the entire universe. Gravity acts on everything with mass. It keeps your feet on the ground, the moon around Earth, and planets around stars. Without gravity, the universe as we know it wouldn't exist. But here's where things get strange. Gravity doesn't just pull objects together. According to Einstein, it actually bends space and time itself. Not because they're being pulled in the traditional sense, but because space itself is curved, and gravity can even affect time. The stronger the gravity, the slower time passes. Right now, time is moving slightly slower on Earth than it is far out in deep space. And here's something even stranger. Tiny difference, but measurable for hundreds of years. Scientists have tried to understand this force. Newton showed that every object attracts every other object. Einstein revealed that gravity is far stranger than anyone imagined. And even today, we still don't fully understand it. Because gravity remains one of the greatest mysteries in physics. So here's the question. If gravity can bend space and slow time, what else might it be capable of? What would happen if two entire galaxies collided? Would stars smash into each other? Would entire solar systems be destroyed? The truth is far stranger. Right now, our own galaxy is on a collision course, and one day, the Milky Way will collide with another giant galaxy, a cosmic impact on a scale almost impossible to imagine. But here's the surprising part. Almost no stars will actually collide, not because the collision is gentle, but because space is mostly empty. The distance between stars is so enormous that even when two galaxies pass directly through one another, most stars simply miss. They continue their journey through the chaos. Yet that doesn't mean nothing happens. Far from it. Gravity begins to reshape everything. Stars are pulled into new orbits. Spiral arms become distorted. Entire galaxies stretch, twist, and transform. Over hundreds of millions of years, two separate galaxies can become one. Meanwhile, the visible gas clouds slam together violently, creating enormous shock waves and triggering explosions of star formation. Thousands, millions of new stars can be born, all because two galaxies crossed paths. The event is completely silent. No explosion, no roar, no sound at all, because in space, there is nothing to carry it. Just darkness, gravity, and time, slowly reshaping the universe. And perhaps the most incredible part is this. Galaxy collisions are not rare. They are one of the main ways the universe evolves. Right now, somewhere in the cosmos, entire galaxies are merging, stars are being born, black holes are growing, and the structure of the universe is changing forever. What if you fell into a black hole? Not a science fiction version, a real one of the most mysterious and terrifying objects in the universe. A black hole is a region of space where gravity becomes so powerful that nothing can escape. Not matter, not signals, not even light. Surrounding every black hole is an invisible boundary, the event horizon. Cross this line, and there is no return. No matter how powerful your spacecraft, no matter how advanced your technology, once you pass the horizon, you are trapped forever. For decades, scientists believed black holes were incredibly simple objects, according to a famous idea known as the no-hair theorem. Every black hole can be described using only three properties: mass, spin, and electric charge. Nothing else. No memory, no details, no history. Everything that falls inside is erased from the outside universe. You would never actually see a black hole itself, because black holes are truly dark. They emit no light, no glow, no visible surface. So how do we know they exist? Because we can see their shadow. As hot gas spirals around the black hole, it heats up to extraordinary temperatures. The glowing material creates a bright ring, and at the center, a dark silhouette appears, the shadow of the black hole. In 2019, humanity captured the first image of one, a moment that changed astronomy forever. But black holes have another strange ability. They can bend light itself. Their gravity warps space, like a giant cosmic lens. Light from distant stars is stretched, distorted, and magnified, creating bizarre visual effects known as gravitational lensing, a natural telescope built by the universe itself. And, despite their terrifying power, black holes may help shape galaxies, influence star formation, and control the evolution of entire regions of the universe. They are not simply destroyers. They are architects, silent, invisible, and almost beyond comprehension. How does a star begin? Not with fire, not with light, but with darkness. Before every star, before every sun, before every source of light in the night sky, there was only a cold cloud of gas and dust, floating silently through space. These enormous structures are known as molecular clouds. Some stretch across hundreds of light years, containing enough material to create millions of stars. Then something changes. A nearby supernova explodes, two giant gas clouds collide, or a passing wave of energy disturbs the balance, and suddenly, gravity takes over. Gas begins falling inward. Dust follows. The cloud starts to collapse. Slowly, the material gathers together. As it falls, it accelerates, heating up, spinning faster, forming a giant rotating disk. And deep within that disk, something new is born. Deep within the protostar, temperatures continue to rise until something extraordinary begins. Nuclear fusion, the process that powers every star in the universe. For the first time, the star ignites. A new sun is born, and with that ignition, a cosmic battle begins. Gravity pulls inward. Fusion pushes outward. For a brief moment, the two forces reach perfect balance. The collapse stops. The star stabilizes and enters the longest chapter of its life, the main sequence. Right now, somewhere in the observable universe, new stars are forming. As you watch this video, as you breathe, as you look up at the night sky, the story continues. So here's the question. If every star begins in darkness, how many future suns are hidden in the shadows of the universe right now? What is the most powerful explosion in the universe? Not a nuclear bomb, not a gamma ray burst from science fiction, but the death of a star, a supernova. For a brief moment, a single dying star can outshine an entire galaxy. Billions of stars combined. In just a few days, a supernova can release as much energy as our sun will produce during its entire lifetime. But how does something so powerful actually happen? The answer begins with a massive star. A star at least 8 times heavier than our sun. For millions of years, it survives through a delicate balance. Gravity pulls inward. Nuclear fusion pushes outward. As long as fusion continues, the star remains stable, but no fuel lasts forever. Eventually, the star begins to run out. Fusion slows, the outward pressure weakens, and gravity finally takes control. The core collapses inward at incredible speed, faster, denser, hotter, until the pressure becomes almost unimaginable. In a fraction of a second, the core is crushed. What remains may become a neutron star, or something even more extreme, a black hole. But the collapse itself is only the beginning. The sudden implosion creates a violent shock wave, one powerful enough to rip the star apart. The outer layers are blasted into space at millions of kilometers per hour, and the star dies in a colossal explosion, a supernova. But perhaps the most incredible part comes after the explosion, because supernovae do more than destroy, they create. Inside stars, elements are forged: oxygen, silicon, iron, and during a supernova, those elements are scattered across the cosmos, becoming part of future planets, future oceans, future mountains, and eventually, future life. And supernovae help us understand something else. The universe itself, a special type of supernova, explodes with nearly the same brightness every time. So the next time you look up at the night sky, remember this: some of the most beautiful things in existence were created by destruction. Entire worlds, entire civilizations, even you, all born from the ashes of ancient stars. What if I told you that most of the universe is invisible, not hidden, not far away? Invisible. Right now, everything you can see, every star, every planet, every galaxy, makes up only a tiny fraction of what actually exists. The rest is something we cannot see, cannot touch, cannot detect directly. Scientists call it dark matter, one of the greatest mysteries in the entire universe. And here's the strange part: we know it exists, even though nobody has ever seen it, because its gravity is everywhere. In fact, without dark matter, galaxies shouldn't exist at all. According to the gravity produced by visible matter, those stars should fly away. Galaxies should tear themselves apart, but they don't. Something unseen is holding them together, like an invisible skeleton supporting the entire structure. Dark matter acts as the cosmic scaffolding of the universe. Without it, the cosmos we know would look completely different. But perhaps the most fascinating evidence comes from light itself, because dark matter can bend light, not directly, but through gravity. According to Einstein, mass bends space and time, and dark matter has mass, a lot of it. As light travels across the universe, it passes through enormous concentrations of dark matter. The light bends, stretches, distorts, creating a phenomenon known as gravitational lensing, a giant natural magnifying glass created by the universe itself. By studying these distortions, scientists can actually map where dark matter is located, even though they still can't see it. Think about that. We can map something that remains completely invisible. And yet, after decades of research, we still don't know what dark matter actually is. And that's what makes dark matter so fascinating. It surrounds us, shapes galaxies, controls the structure of the cosmos, makes up most of the matter in existence, and still, we have no idea what it truly is. So here's the question: if 85% of all matter in the universe is something we cannot see, how much of reality are we still missing? Welcome to the dark universe.